Welcome to this explainer. When we think of Antarctica, we naturally picture, well, an endless expanse of white ice, right? And while we know it's a massive frozen continent, the sheer scale and extreme dynamism of what is actually happening miles beneath that surface, it's literally shocking, even to the experts who study it every single day.
It's so easy to just assume the environment down there is simply a static, frozen wasteland. But recently, the scientific consensus has dramatically shifted. Instead of viewing the subglacial environment as this massive, dormant deep freeze, researchers are uncovering an incredibly active frontier. We're talking about a world that is constantly shifting and evolving.
But what if a weird, upside-down world lurks beneath all that ice? Let's take an elemental journey down through the ice and into the unknown, uncovering secrets that are fundamentally rewriting our understanding of the planet.
Okay, let's dive right into this. Act 1, water. Specifically, subglacial lakes. Imagine descending half a mile deep into the pressurized pitch-black waters of Antarctica's subglacial lakes. Starting with a place called Lake Vostok, researchers drilled 800 meters straight through the ice and made a staggering discovery. 3,900. That is the astonishing number of kinds of microbial life found living down there. They didn't find a sterile void. They found a bustling, microscopic metropolis, surviving without a single drop of sunlight.
So how on earth does anything survive in sub-freezing, pitch-black waters? Well, this bizarre ecosystem actually thrives completely without photosynthesis. Instead, these bacteria feed off the oxidation of ammonia and methane from ancient sediments. We're talking stuff laid down at least 120,000 years ago, and honestly, it gets crazier. Near the transition point to seawater, cameras have actually captured surprisingly complex life. Crustaceans, jellyfish, and even fish up to 20 centimeters long, just swimming around in the dark, frigid waters right below the ice shelf.
Now, the deeper you go, the weirder it gets. Over at Lake Vostok, which is the largest subglacial lake on the continent, buried beneath over 2 miles of ice, Russian scientists found something absolutely mysterious. When they extracted DNA from an unidentified organism, it was less than an 86% match to any known species in global databanks. No way, right? As Sergei Bulat from the Petersburg Nuclear Physics Institute put it, if it were found on Mars, people would call it Martian DNA. But this is DNA from Earth.
Moving on to Act 2, Earth. Let's look at the tectonic forces at play here. We're transitioning from these hidden liquid lakes down into the solid bedrock itself. Beneath all that ice, the continent has been shaped by incredible tectonic forces and, honestly, cataclysmic cosmic impacts. Around 250 million years ago, a massive asteroid struck what is now Wilkes Land. It created a giant crater that scientists believe could actually be linked to the mass extinction ending the Permian period. Jump ahead to 180 million years ago, and the massive supercontinent of Gondwana begins to splinter apart. Finally, around 70 million years ago, Antarctica and Australia permanently separated, leaving Antarctica isolated to freeze over.
But this tectonic splitting wasn't exactly clean or simple. It involved a really fascinating process called distributed rotational extension. Basically, this is a tectonic process where the Earth's crust deforms outward from a fixed central point. This massive deformation is exactly what's responsible for ripping open the enormous basins concealed deep beneath the East Antarctic ice sheet today.
To picture this, imagine the geological structure as a human hand with outstretched fingers. The crust fans out from a central point, and the gaps between the fingers form these massive, deep triangular basins. It's like a giant puzzle, linking famous areas like the Wilkes Basin, the Aurora Basin, and even the basin hosting Lake Vostok. It just goes to show us that East Antarctica isn't just some old, stable block of rock. It has a remarkably dynamic tectonic history.
And now for the grand reveal. Act 3, Fire. Let's talk about subglacial volcanoes.
So we've seen the liquid lakes, we've mapped the stretching bedrock, and now we really have to confront the volatile world of magma and peaks sitting right beneath the West Antarctic ice sheet. 138. Scientists have recently identified an incredible 138 volcanoes hidden completely under the ice. And get this, 91 of these subglacial peaks are newly discovered. They've just been sitting there, totally unknown to us, buried under miles of frozen water.
Now, what's really interesting about this is the sheer concentration of these peaks. Using ice-penetrating radar, aeromagnetic data, and satellite imagery, researchers mapped how heavily concentrated these volcanic cones are across the West Antarctic Rift System. I mean, this volcanic province spans a massive 3,500-kilometer stretch, going straight from the Ross Ice Shelf all the way up to the Antarctic Peninsula.
To truly understand the scale here, we have to look at the East African Rift System, which is currently acknowledged as the densest concentration of volcanoes in the world. Well, geologists now believe that the West Antarctic Rift System is highly comparable. In fact, Antarctica might just hold the title for the single largest and densest volcanic region on our entire planet. How wild is that?
And these are definitely not just small geological bumps. We are talking about hidden peaks towering up to 3,850 meters tall. To put that into perspective for a second, the largest of these hidden volcanoes is practically as tall as the famous Eiger Mountain in the Swiss Alps. It's literally an entire alpine mountain range completely swallowed by ice.
So, bringing it all together, why this hidden world matters.
Okay, so we have bizarre subsurface lakes, massively fractured continental bedrock, and possibly the world's largest volcanic range. But why does this actually matter for you and me? Well, it creates a highly dangerous potential feedback loop. Step 1. As our global climate warms, the Antarctic ice sheet naturally thins. Step 2. Less ice means less physical weight and pressure on the continent's crust, which scientists warned could actually cause this hidden volcanic activity to increase. And Step 3. If these subglacial volcanoes wake up and emit geothermal heat, they will melt the ice sheet from the bottom up, which would drastically accelerate sea level rise worldwide.
But you know, it's not just about Earth's climate. It's also about our place in the universe. Remember that Martian DNA in the deep lakes we talked about earlier? Antarctica's pitch-black, pressurized, ice-covered ecosystems act as the perfect scientific stand-in for the icy moons of our solar system. Specifically, Jupiter's moon Europa and Saturn's moon Enceladus, both of which hide vast, mysterious oceans beneath thick, icy crusts. By understanding how life feeds on ancient minerals in the dark and how volcanic rifts shape a frozen continent right here at home, we are literally practicing for the search for extraterrestrial life. Which leaves us with one final, really profound question to consider. If a thriving, fiery, alien world can exist entirely hidden beneath our very own ice here on Earth, what incredible secrets remain hidden out there, across the dark, icy reaches of our solar system? Thanks for joining me on this explainer. I hope it completely flipped your view of the world upside down.